you use to me. Okay, so I'm combining these. So I have here negative 4x plus 4x. Those are opposite. You know that goes to 0, so my x terms are gone. 5y plus 6y is, there you go, 11y. Equals, bring it down, 17 plus negative 6, so 17 minus 6 would give me, there you go, 11. I want to get y by itself, so we're trying to isolate the y. So now I'm going to divide both sides by 11. Okay. So they cancel out because that's the quotient is 1. I'm left with 1y equals 11 divided by 11 is 1. So I know y is 1. Okay. And some of you may be like, well, Miss May, how do you know which variable to eliminate? Whichever one, in these cases, in the 3, notice that if they was additive inverses, we automatically eliminate those if they're opposite. Okay, so the ones that's opposite, that's what I'm going to eliminate. Here, you probably, well, both of these was opposite, and both of those got eliminated, and that's the reason we had no solution. Okay, good. So back to example 3. So we solved for y, we found the value was 1. So I'm going to take this 1 for y, and I'm going to substitute in either the number 1 equation or the second equation. It doesn't matter. Okay, so I'm going to choose the first equation. Okay, so I'm going to write negative 4x plus 5y equals 17. And now I'm trying to solve for x. I want to know what does x equals because I know what the y equals. Therefore, I'm going to substitute in 1 for y. So I'm write negative 4x plus 5 times 1 equals 17. So I have negative 4x plus 5 times 1 is 5 equals 17. Subtract 5 from both sides, just solving the two-step equation now. That cancel, bring down my negative 4x equals 17 minus 5 is 12. Divide both sides by the coefficient of x, which is negative 4. Negative 4 divided by negative 4 is 1. That leaves me with 1x equals 12 divided by negative 4 is negative 3. Okay. So my point of intersection, since I had variable statements, I have a point of intersection, and that point of intersection for this system of linear equation is negative 3, comma 1. This is my solution. That's my solution. That's my point of intersection. And you press so, you know, I know how the graph will look. It will be intersecting lines. Okay. So there we go for that. That was example 3. Now on example 1, 2, and 3, they had given us additive inverses. Now the next examples I do, we're gonna do a little more steps. Okay. So example 4, it's gonna have a little more steps for you guys to do. Okay. So we're gonna have here the first equation is 2x plus 3y equals 4. Okay. The second one is negative 4x plus 6y equals 9. We have our system of a linear equation, and I like the number 1 and 2. Now what you notice is that, let me make sure this, you can see this plus sign here. Okay. So now what you notice is that we have no additive inverses. Here for my x terms, I have 2, and I have a negative 4 for the coefficient. For the coefficient y, I got a positive 3 and a positive 6. So they're not additive inverses. When they're not additive inverses, and I'm using the elimination method, I have to make them additive inverses. I have to make them opposite. It doesn't matter if I make the x terms opposite or the y terms. It's up to you. You would get the same solution if you choose to solve for x or eliminate x and someone else choose to eliminate y, you will still get the same results at the end. Okay? So I'm going to eliminate x because at least they are opposite sign. I have a positive number and a negative. Okay? So my first step would be to make this x term coefficient the opposite of this one. This is negative 4, so I'm going to make this positive 4. Okay? How do I do that? The first step, I'm going to take this equation and I'm going to multiply it by 2 because I know 2 times 2 is 4. I know 2 times 2 is 4, and that's the opposite of negative 4. So I'm going to say 2x plus 3y equals 4. I'm multiplying the entire equation. Okay? So I'm going to say 2 times 2x, that is going to be 4x. 2 times 3y, that's going to be 6y. 2 times 4 is 8. This is my first equation now. Okay, it's the same thing. Okay? So now what I'm going to do, I'm going to write my first equation, 4x plus 6y equals 8. My second equation is negative 4x plus 6y equals 9. Okay. Now I have additive inverses. Okay. And I could do it the way we did example 1, 2, and 3 now. Okay. So what I'm going to combine these equations with the addition. Oh, you could just say combined it. I'm just writing addition because that's exactly what we're doing. We're combining them. Okay. So opposite, additive inverse is 0. The sum is 0. That's gone. This is positive 6y plus another positive 6y. Or that'll give me 12y. Sorry. Okay. So that's going to give me a positive 12y. Did I do that? Yes, yes, yes. Okay. And equals 17. Okay. And once I have that, I'm going to do what? Yes, I'm going to solve for y. And I'm trying to just make sure that I wrote my information down correctly for negative 4x plus. Okay, I got it. And I make sure you do your distributor because I got 2 times 2, that gave me 4. 2 times 3 is 6. 2 times 4 is 8. Okay, so I got the 8 there. I wrote down negative 4x plus 6y equals 9. That cancels. I got 6y plus 6y. I have 12y. 8 plus 9 is 17. I'm going to divide both sides by the coefficient of y, which is 12. The 12 cancel here because 12 divided by 12 is 1. So I'm left with 1y equals 17th 12. Okay. Good. It's okay to get fractions. Fractions are numbers. Okay. So now what I'm going to do, I'm going to take those, and I love it. I'm going to take this y value and do the same thing. I'm going to substitute this y value into either one of the equations. It doesn't matter. I can substitute it into 1 or 2. Okay. So I'm going to, I think I do 1. So I'm going to take 1 and I'm going to substitute the 17/12 in so that I can get the x value. So I'm going to say 2x plus 3y equals 4. I'm going to write it down at least. I'm going to say 2x, or write 2x plus 3 times y, which is 17 over 12, equals 4. 2x plus, go to the side and multiply that, or put in your calculator, and it'll give you whatever it'll give you, okay? So here, what I've noticed here, 3 times, I'm going to go to the side. 3 over 1 times 17/12, okay? Cancel out if you're doing it by hand. Numerator, denominator. 3 going to itself 1 time, 3 going to 12 4 times, so it's 17/4. So I have plus 17/4 equals 4. Okay. Subtract both sides by 17/4. It doesn't matter, it's a fraction. That cancel. I'm left with 2x equals 4 minus 17/4. Make your denominators the same. So I have here 4 over 1 minus 17 over 4. Here, I want a 4 there, so I'll multiply the numerator and denominator by 4. So I have 16 over 4 minus 17/4. So that'll give me negative 1/4. So that equals negative 1/4. Okay. And guys, if you have access to a calculator, you can do it on a calculator. You don't have to go and do what I did. Okay. Divide both sides by the coefficient, which is, oh, sorry, guys. So that, look. Okay, the coefficient of x is 2. Divide both sides by 2, so that leaves me with x equals negative 1/4 divided by 2. So go to the side, or negative 1/4 divided by 2. Okay, since these are fractions, and we know if a negative divided a negative, it's going to be a negative. Since these are fraction, or this is a fraction, you're going to multiply by the reciprocal. Okay, so I'm going to say negative 1/4 times the reciprocal of 2, which is 1/2. Okay, so negative 1/8. So here we go. You'll be like, oh, we can get fractions. Yes, honey. So I know my point of intersection is going to be negative 1/8, comma, 17/12. 12. Okay. So that means I have intersecting lines. Now I will tell you guys, you probably said that you do need to verify. Okay. I don't care if you say, oh, this looks so ugly, I don't want to verify this by hand. Well, you